Hello and welcome to this walkthrough of Amplify Science for grades 6 through 8. My name's Matt, and let's go ahead and get started. Amplify Science, it is a partnership. It's a partnership between the Lawrence Hall of Science, based out of UC Berkeley in California, and Amplify, based here in Brooklyn. So LHS, they have been developing various science curricula for pretty close to 50 years. And indeed, Amplify Science is the latest program out of LHS, and it is the only one that is designed for the three dimensions of science instruction. So they are the writers of the program and all of the content in the program. Amplify, we developed the technology on which the program is served, developed all the digital tools that you're going to get to see in a little bit here. As I just mentioned, Amplify Science is really designed from the bottom up for the three dimensions of science education. So you're going to see as I go through lessons how students are engaging in doing the science and engineering practices in order to figure out disciplinary core ideas, of course within the framing and context of they're figuring out real-world scientific phenomena, and gaining greater experience with and applying their understanding of cross-cutting concepts to help link topics across science domains and indeed to help them figure out these scientific phenomena. But do not take my word for it, because the group Ed Reports, the third-party group, they did a review of middle school science products and programs, and of all of the programs that they reviewed, only one, hey, it's ours, Amplify Science, only Amplify Science was rated, as they say, all greens, meaning across their different criteria, Amplify Science got top marks, and including in those is that it's designed for these new approach, the three-dimensional instruction. Indeed, even they recognized how we really embrace this and actually are designed for it. So check that out if you haven't already. How do we go about doing this, though? So let's look at this. This really helps. This is kind of the skeleton, the bones, the basic structure of every unit here in Amplify Science. Left to right, beginning to end of a unit. Every unit begins with students taking on the role of some type of scientist or engineer in order to investigate a real-world problem, a 21st century problem. And so in this problem, students are figuring out the scientific phenomena, and oftentimes multiple types of phenomena within a single sort of storyline, if you will. So I've got a type of role, I'm a kind of scientist, I've got a problem I'm investigating. We then, in our lessons, start collecting evidence from multiple sources and through multiple modalities. Talk more about that in a bit. And we are then piecing them together, making sense, developing evidence-based explanations and models and iterating on models, and we're constructing increasingly sophisticated understanding and explanations of the phenomena that we are investigating. And that just leads us to be exposed to more and more and to collect more and more evidence and to go deeper and deeper. That's what's really driving the units forward as I go from lesson to lesson. At the end of the unit, you'll see it's chapter 4. We'll get there. At the end of the unit, we conclude that main investigation, and right at the end, there's a new opportunity where we present students with a brand new problem they have not seen before. They have to take everything that they've learned thus far and apply it to this brand new problem. Really a great opportunity to demonstrate deeper levels of understanding. So I will be able to show you that in a little bit here. Let me make this a bit more concrete. I've got 3 examples here of 3 different units in the program. Our unit on genetics, for example, students are working to figure out medicinal uses of spider silk. And they're presented with this problem where when I breed 2 spiders, 2 Darwin bark spiders, sometimes the offspring resemble parents, sometimes they don't resemble their parents at all with different traits, and it's through that we're figuring out all these ideas related to genetics. What about in the unit that deals with freezing and melting and evaporation? We're talking about phase change. In that unit, we are planetary chemists, and we are investigating the true story, right, of how the Cassini spacecraft took a picture of Titan, one of Saturn's moons, and one year it detects lakes of liquid methane on Titan. The spacecraft then returns a few years later, takes another a picture of the same spot, and those lakes of liquid methane disappeared. What happened to the lakes of methane on Titan? That's the real-world problem through which we get to investigate this phenomenon of phase change. Finally, what about the unit that has to deal with different types of waves, light waves and sound waves? And we're learning about why does Australia have a higher incidence of skin cancer than anywhere else in the world? Really engaging context and phenomena through which to explore light waves. So those are some basic examples for you. But here's something. So I've given you a sense of why it's designed for the new standards and the new approach of three-dimensional instruction. And it's been reviewed by a third party, just so you don't have to take my word for it. Got it. But here's another thing that's really important to the core design of the program. And that is that we designed this program with all students in mind. We wanted all students to be supported. We wanted all students to be able to achieve and really master these standards. And that's not something, you're going to see how we have lesson level supports and differentiation strategies and unit level supports and differentiation strategies. And you're going to see indeed how different parts of specific lessons, how we do it. But I'm talking about something different. I'm talking about the basic design of the program. How does it really ensure all students, all standards? Here's how. It's sort of the special sauce of Amplify Science, and it's this idea of multiple modalities. And what I mean is that for every basic idea, science idea that students come up against and are first introduced to in our units, each student, the class, we're going to get to engage with that idea several times, and each time through a different modality. Right? So another way that we say this is, each student has multiple at-bats with a given idea. So we might do a hands-on investigation with this idea, then we might have a discussion and talk about the same idea, and then read a science article about that idea. For those students who are struggling, they have several opportunities and ways through which to engage with that idea and to come to terms with it. For those that are sort of more high-performing students, well, this actually gives them an opportunity to truly deeply understand these ideas and scientific phenomena, not simply to just memorize what one could call the, air quotes, answer, close quotes, but really to be able to understand it on a deeper level and to provide an explanation and a model of such. This is a really important bit to our approach here. And we've got the data to back up the efficacy of this approach. We have 3 gold standard studies showing that this approach really helps students when it comes to reading comprehension and vocabulary and content knowledge, to students' writing improves dramatically due to they're able to show their deeper level of understanding. And something, me, Matt, I'm particularly proud of is that, as you can imagine, this is really supportive of English language learners. How those students are really able to engage with a single idea multiple times through multiple modalities. It really helps with English learners as well. In addition to this, as I've already alluded to, there are lesson-specific differentiation strategies. I'm going to show this to you because I'm going to stop using slides in a second and go into the program. But lesson-specific differentiation strategies, every lesson has ways to support students who need some extra support, has ways to support English language learners, and it has ways to support those students who are looking for additional challenges. Every lesson has this, okay? One step more granular, that was at the lesson level. Each lesson is made up of what we call activities. Every lesson can have anywhere between 3 to 5 or 6 different activities. There are indeed activity level supports as well. Anything from supports for the teacher who can help students engage in this specific activity. What's up on the screen here is to help students who are about to engage in a reading activity. And here's another example for those students maybe who want a little bit more exposure to another idea for this hands-on activity that's part of a separate lesson here. So we've got supports at all levels and differentiation approaches at all levels of the program. Okay, here's an important bit again, is that imagine I come into one of the units of Amplify Science. Ultimately, we know what the end goal is. The end goal is the standards at the end. But the gap between starting a unit and concluding a unit with ostensibly mastery, that's how do we map that out? Well, here in Amplify Science, we make this really clear, and we have very clear unit coherence. How do we build in a unit? And so what we do is that we have these learning progressions embedded in every unit that very clearly break down what are students expected to know by the end of Chapter 1, Chapter 2, and so on. And so these all build on each other, and you'll see how the assessments really help gauge on this scale where are students at a particular moment. So we really can show a deep and really map student progression from prior knowledge to deep causal understanding and ability to give an explanation. Here's a broad overview of our assessment approach from pre-unit assessments starting the unit to while we're in the unit and in the lessons there are on-the-fly assessments, kind of like a quick check, unobtrusive assessments. There are self-assessments. In the middle of the units, there's a critical juncture assessment, which actually how students perform on that critical juncture drives a very special lesson that happens after that mid-unit assessment, the critical juncture, which is really a full day dedicated to differentiation. We're right in the middle of the unit. The students take this assessment, and the following day, they get individualized activities. Well, they're grouped up, and each group gets an activity based on how they scored on the assessment. And that's a great moment to kind of catch your breath collectively as a class, give the students who are struggling some extra attention and support, challenge those students who are where they should be, so to speak, and then following on for the latter half of the unit, we can move on as a class together. Great example of a unit level differentiation support. And of course, at the end of the unit, there's an end of unit assessment from multiple choice and written responses to, I'm going to show you guys this, the use of science seminars where we get to have these oral student-to-student discourse and presentations to discuss these scientific phenomena. Here's actually a view of what it looks like when students took a test. You can see how the technology actually auto-groups them. And at the mid-level, at the mid-unit assessment, you even deliver specialized content depending on the groups. We also have benchmark assessments, which are really designed to kind of be a separation of standards from content. If you were interested, we could talk about how really standards-based, I'm assessing students standard by standard. We have this available as well. When it comes to pacing and materials, here's an example of what one grade level could look like, but we're generally looking at about 145 lessons per grade level. Different types of units. There's a launch unit, which is a short unit. There are engineering internships, of which there are 2 per grade level. Those are shorter units as well, and the rest are called core units at 19 lessons apiece. Teachers have availability to printed teacher's guides or to a digital teacher's guide, which is what I'm going to be clicking through in a moment here. There are classroom wall materials, vocabulary, key concepts, questions that are posed and indeed responded to. And I should mention that all of this is available in Spanish as well for those classroom wall materials, and there are really powerful Spanish supports in the digital teacher's guide. So those are in terms of teacher materials. Student materials, the buzzword here is flexibility. Everything that you could see that should be available in paper is available in paper. So let me give you a couple examples here. There are readings, you can see it in the center of the screen, science articles that appear in various lessons. Those are available digitally. Right? Students can go on the devices and access those. Those are downloadable as PDFs. Or indeed, they are available in print, pre-printed, so that if teachers prefer to do that in print. Students, when it comes time to respond and fill out data tables and write down responses, we have notebooks for that. Same idea. That stuff is available digitally, it's available for download, or it's available already supplied in print, and indeed available in Spanish as well. Every unit has a kit with hands-on materials that are called for in various units, in various lessons within the unit. Each unit has a digital simulation, which really complements those kits well, so we can explore some more unseeable and unobservable scientific phenomena. So you see how we use digital simulations. And indeed, as I kind of alluded to, if you wanted your students going on the devices to respond to questions and to take their assessments, there's an entire digital student experience where they can log in and put their responses in that way as well. With that, let me quickly highlight some other features and just sort of show it to you in real time here. So I'm going to pop away from my slides. I am in the digital teacher's guide for one unit. This is the metabolism unit. I can indeed download the entire teacher's guide. Furthermore, there are a wealth of supporting documents. Teachers do not have to read all of these, but it's helpful stuff, right? Do you want to know what's inside of the kit for this unit? That's very readily available for you as a teacher whenever you need it. Do you maybe need a little bit of a refresher on the science that's called for in this unit? Every unit has science background, just meant for the teacher. There's overviews of the standards, the assessments, and where there are embedded unobtrusive formative assessments, information on the articles and the apps, and flextensions. Those are flexible extensions, additional hands-on heavy activities that teachers can use if they'd like, and it calls for common materials found in science classrooms. All of this stuff is available for your teachers whenever they need it. When I go into a chapter here, I'm going to pop into the first chapter of this unit. You can see the pre-unit assessment there. As I go into a lesson, I can see how the lesson is broken down. I have an overview giving me a sense of what students are going to be learning in this lesson, a quick sense of pacing of the different parts of the lesson, any materials and prep to set up this lesson. As I mentioned, those differentiation strategies. Here it is for this one lesson. All of these differentiation strategies just for the single lesson here. Definitely encourage you to check that out. Teachers, you can download this lesson if you want to have this on paper at your side. Some folks prefer that. Again, sort of the blended nature is something we're really proud of here at Amplify Science. When I go into this lesson, it's going to start with a video. This is what introduces students to the role that they're taking on. And in this metabolism unit, we are medical interns looking to diagnose a young patient with a possible medical condition. So the video here introduces students to their role and to that problem that we'll be investigating. As you can see, the lesson then goes on to a warm-up where students are we're kind of eliciting their prior experience here with what students know and what are their ideas about why the patient is feeling tired all the time. You can see there are step-by-step teacher instructions to help you deliver the activity. I could also hide that if I want to see what the student screen looks like in this sense. You can see there's step-by-step instructions. There's that in-context extra level of support in the teacher support notes, giving you everything from background information, instructional routines and explanations, and indeed extension activities available here in the teacher support tab. Possible responses is just an answer key for you, right? This lesson goes on into a classroom conversation, and we end up using a simulation in this lesson. Really easy to access that simulation. And again, you can see how each lesson is a little bit different. This one is about a video and a warm-up, a conversation and a simulation. Another lesson, a little bit later on, for example, as we pop in here, here's a warm-up activity, but we're really focused on a reading in this lesson. We're going to be reading an article and then discussing all of the annotations that we have of this article in this lesson. Whereas to go ahead to the next chapter, chapter 3 here, this lesson, one of my favorites, it's a warm-up followed by a really cool hands-on activity where we then do a quick little reading that connects to the hands-on. We then go back to our sim and we have a discussion to wrap it up. So you can see every lesson is a little bit different, calling for different materials, all of these lessons building on each other. In this particular unit, chapters 1, 2, and 3 are all about diagnosing our patient, Elisa. I'll give it away to you. Indeed, she has diabetes. Chapter 4 then is that opportunity to we conclude the main investigation and we're presented with a brand new opportunity. And in this chapter, we get to apply what we learned in chapters 1 through 3. In this chapter, students learn about an athlete who's been accused of blood doping. And indeed, we have a great video that kind of introduces the problem and they end up reading a really great article, which is great for students and it's even great for adults to learn a little bit more about blood doping, which we know, you don't actually have to use drugs for blood doping. It's just where athletes extract their own blood from their body, they freeze it, and they re-inject their own blood back into them, thereby increasing the concentration of red blood cells in their system. And indeed, we know that those red blood cells carry oxygen, so with a little bit more glucose, we can actually have greater amounts, releases of energy. So here in chapter 4, students look at a whole bunch of different pieces of evidence, and it's a great opportunity for them to demonstrate an understanding of cellular respiration before they come together in a science seminar where Students get up, present evidence that they think is strong. They get to say which of a number of claims they think is best supported by evidence. Have a great student-student discourse exercise there before finally taking their end of unit assessment. That, in a nutshell, is kind of the Amplify Science program. And as I skip to different units in the program, you'll see it's the same basic approach. So with that, I hope you've learned a little bit more about Amplify Science, seen how it was designed for the standards, how it really embraces differentiation and supports at all levels of the program, how the program really is blended. And anything that is that could be available on paper is indeed available on paper as well. So with that, thank you so much for joining me here. And I'm just going to send you out with a little bit of playing around here with the simulation that's used in that genetics unit as I breed up some spiders here. So thank you again, and I hope you have a great day. And why don't I go ahead and show you the simulation from the metabolism unit. As you can see, as I put some food into the digestive system, starches are breaking down into glucose in the small intestines, proteins down into amino acids, which all make their way into the circulatory system, where they're joined by some oxygen which came in from the respiratory system, and all of this making its way down to the cells in our body. This visual is helpful, but there's actually some really other great and really cool aspects of this simulation. One is that what we're looking at right now is a healthy body, but I could run this as if it were a patient who had diabetes. We'd see fewer glucose molecules making their way into the cells of our body in that example. But seeing it is one thing. We're right now in live view, but the data behind it is actually going to be really valuable, and it's needed in several lessons. So we go to graph view here. You can see this is actually a data collection tool as well. So again, the sim, you could see how this really would complement the readings and the hands-on activities in that unit where we're trying to diagnose our patient. Another one just for that sort of transition there of the readings. Here's what the readings look like when you access them digitally as a teacher or as a student. So I can come in here. A couple things you could see. Vocabulary, there are in-context definitions of vocabulary words with the translations in Spanish. I can highlight. I can change the color of those highlights if I'd like. I can go ahead and add annotations, which is really what the lessons ask students to do. Come up with observations and questions that they have and things they want to share with the class as you're reading through. You can even annotate the images themselves, and indeed there's a readback feature, so you can hear this article read aloud to you. So with that, you get a sense of the simulations, the readings. You saw a bit about the reporting in terms of grouping of students automatically at the pre-unit, mid-unit, and end-of-unit assessments, also with question level analysis as well. And with that, I think you get a pretty good sense of all the technology involved in the program as well. Again, thanks so much.